My dear students, in this video I am going to continue the properties of vector product. In our previous video we have seen some 6 properties of vector product. The 7th property, vector product in determinant form. Suppose A is a vector given by A1i plus A2j plus A3k, and B is a vector B1i plus B2j plus B3k. So the vector product A cross B is nothing but A1i plus A2j plus A3k cross B1i plus B2j plus B3k. By taking cross product, you know I dot I cross I 0, I cross j k. So A1 B2, I cross j is k. Similarly, I cross k, k cross I is j, I cross k is minus j. See, this is the coordinate system Ox, Oy, Oz are the mutually perpendicular coordinate axis. Y-axis, j cap is the unit vector acting along y-axis, I cap is the unit vector acting along x-axis, k cap is the unit vector acting along z-axis. So I cross j. So anti-clockwise sense you get positive vectors. I cross j is k, j cross k is I, k cross I is j. Here I cross I 0, I cross j is k. So A1 B2 into k, I cross k in the clockwise direction it is minus j. So minus A1 B3 into minus j, because I cross k is minus j. So A1 B2 I cross j is k minus A1 B3 I cross k is minus j, therefore minus j, minus A1 B3. Similarly, next one, j cross I is k, j cross I minus k, because in the clockwise sense j cross I is minus k, therefore A2 B1 minus A2 B1, j cross I minus k, and j cross j 0, j cross k I plus A2 B3, j cross k is I cap. And finally k cross I is j, so plus A3 B1 into k cross I is j, and k cross j is minus I, so minus A3 B2 A3 B2, k cross j is minus I, so minus A3 B2, and k cross k is 0. So now you collect the terms, I terms A2 B3 minus A3 B2, A2 B3 minus A3 B2 into I cap. A2 B3 minus A3 B2 into I cap. Similarly, j. If you take minus outside, minus A1 B3 j, A1 B3 minus A3 B1, A1 B3 minus A3 B1 into j. If I take minus term outside, this is A1 B3 minus, plus if you take minus outside, you get minus A3 B1 into j. Similarly, k term plus A1 B2 minus A2 B1 into k cap. So this is nothing but, this expansion is nothing but the determinant form. First row I, j, k, A1, A2, A3, B1, B2, B3. If you expand this determinant, you will get I vector into, you know that the expansion of determinant, eliminating I column and I row, I vector into A2, B3 minus A3, B2 minus J into A1, B3 minus A3, B1 into J plus K cap, K column and K row, you eliminate it, you will get A1, B2 minus A2, B1 into K. So, the cross product of A cross B is nothing but the determinant ijk. First row is components of A vector and second row is components of B vector. So this is nothing but the determinant form of A cross B. Okay? So now using this determinant form, we have to eliminate, we have to find out A cross B by determinant form. You have to find out the vector product of the given vectors A and B by determinant form. That is A cross B equal to, you know by definition, first row ijk, second row minus components of A vector minus 3, 4, minus 7. Third row components of B vector 6, 2, minus 3. Now you expand this determinant, you will get the value of A cross B. That's the vector, you know. That's a vector. A cross B is a vector. By expanding this determinant, you will get I cap into 4 minus, you know the determinant expansion, you know the determinant expansion, 4 into minus 3, minus 12, I vector into minus 12, this is minus of minus plus 14. 2 sevens are minus 14 and the expansion minus will get plus 14. And minus j vector into minus into minus plus 3 3s are 9, minus into minus 3 plus 3 3s are 9. And 6 into 7 minus 42, minus of minus plus 42. Plus k vector into minus 6 and minus 24. 6 4 are 24. This is 14 minus 12, 2i. This is 42 plus 9, 51, minus 51j. 24 minus 24 minus is minus 30k. So this is A cross B. Okay, that's all about the cross product of two vectors given A vector and B vector given. A cross B is just a determinant form, and you will expand the determinant, you will get the vector A cross B. Okay. Next result, angle between the vectors A and B. We have to find out the angle between the vectors A and B. By using dot product, we have determined the angle between vectors in our previous topic, that is cos theta equal to A dot B by mod A into mod B. But in this case, angle between the vectors by cross product, angle between the vectors A and B by cross product. By dot product, you have determined already cos theta formula A dot B by mod A mod B. This is angle between vectors by vector product is, you know A cross B by definition of A cross B, mod of A, modulus of B into sin theta angle between A and B, and n cap is the unit vector acting perpendicular to both A and B. Taking modulus of A cross B from this, modulus of A is mod of A, modulus of B is modulus of B is mod B, modulus of sin theta is sin theta itself, and modulus of n cap, modulus of n cap is 1 because n cap is unit vector, so modulus of n cap is 1. Therefore, this term becomes modulus of A cross B equal to mod A mod B into sin theta only. This is 1. Mod n cap is 1. So, in the result 1, from this result, I can find out angle between the vectors A and B by using sin theta. Keeping sin theta in the right hand side itself, you bring this mod of A cross B by mod A into mod B. This is your result for finding formula for angle between the two vectors using cross product. Sin theta is mod of A cross B by mod A mod, or otherwise theta equal to a sine inverse of mod of A cross B by modulus of A into modulus of B. Sine inverse of. From this you can determine sin theta. Or theta equal to sine inverse of this. A cross mod of A cross B by mod A into mod. See, this vector product gives you only acute angle because sin theta in the first quadrant and second quadrant, both the quadrants, theta is positive. Therefore, this cross product gives you only acute angle. You put as a note, cross product formula, cross product gives only acute angle. Between A and B. This using cross product we can determine only acute angle between the vectors A and B. So whether it is acute or obtuse, it is better to use the dot product formula. That gives you both the acute or obtuse angle. Whether the cross product gives you only acute angle. So it restricted the idea of getting the angle between the vectors. If the angle between the vectors are obtuse, you cannot use this cross product formula. So for that, whether theta is acute, or obtuse, it is better to use dot product formula. Dot product for finding the angle between the vectors. That is, the formula is theta equal to cos inverse of A dot B by mod A into mod B. So this dot product gives you for finding the obtuse angle also. So if you use cross product, it gives you only acute angle. So take it as this as a note for finding the angle between the vectors. And we will solve one problem using this idea. Okay? Now we are going to solve one example. Find the angle between vectors A vector equal to 2i plus j minus k and B vector equal to I plus 2j plus k by using vector product. We have to find out the angle between these two vectors by vector product. For that you have to find A cross B first. A cross B equal to determinant I cap, k cap, j cap, and first second row A vector 2, 1, minus 1. Position 2, 1, minus 1. B vector is 1, 2, 1. And we expand this, you will get A cross B. I vector is eliminating ith row and ith column. 1 into 1, 1. Minus half minus plus 2. 2 into 1, 2. Minus half minus 2 plus 2. And minus j, determine expansion. Minus j into j column and 0. 2 into 1, 2. Minus half minus 1 into 1 plus 1. Plus k cap into k row and k column eliminate. 2 into 4. 1 into 1 minus 1. So this is 3i. 2 plus 1 minus 3j. 4 minus 1 plus 3k. This is where A cross B. Okay. Or you can write it as 3 times of I minus j plus k. If you take 3 as common term, you will get A cross B 3 into I minus j plus 3k. What is mod of A cross B? We want for mod of A cross B. Modulus of A cross B is 3 into mod of I minus j plus k. That is equal to 3 into root of 1 square plus 1 square plus 1 square. I is 1, j is 1, k is also 1. 1 square plus 1 square plus 1 square, 3. 3 root 3. So mod of A cross B is 3 root 3. And modulus of A, we learn modulus of A. formula for sin theta is modulus of A we want, or that modulus of A is root of mod A is 2 square plus 1 square plus 1 square. On squaring minus become plus. So this is 4, 5, 6, 2 square 4, 5, 6, root 6. And mod of B, modulus of B is root of 1 square plus 2 square plus 1 square. B vector is 1, 2, 1. 1 square plus 2 square plus 1 square. Coefficients of I, J, K. This is also 4 plus 1 plus 5, 6. So by formula, angle between the vector sin theta equal to mod of A cross B, 3 root 3, by mod A root 6, mod B is also root 6. So this is equal to 3 root 3 by root 6 into root 6 is 6. Root 6 into root 6 is 6. By cancelling you will get 3 by root 3 by 2 only you will get. Because 3 2s are 6. So sin theta equal to root 3 by 2 implies theta is 60, that is 5 by 3. Theta angle between the vectors A and B is 5 by 3, 60 degree, because sin 60 is root 3 by 2. Theta is 5 by 3. Here you can cancel 3 by 6, you will get root 3 by 2. So theta is 60 degree, that is 5 by 3. That's all about the problem. Okay. Next property, find the unit normal vector. Unit vector perpendicular to both A vector and B vector. You know A cross B is mod of A into modulus of B into sin theta into n cap, you know. And modulus of A cross B is mod of A is mod A, mod of B is mod B, sin theta and modulus is sin theta. But modulus of n cap is 1 because n cap is a unit vector. So modulus of A cross B is mod A, mod B, sin theta. We have seen already in the angle between the two vectors, you can determine this also. Now divide both sides one by one. This will give you numerator A cross B by mod of A cross B equal to mod A, mod E, mod B, mod B, sin theta cancel. These three terms cancel, both the numerator and denominator will get n cap only. So this is the formula for finding the unit vector perpendicular to both A and B. N cap is a unit vector perpendicular to both A and B. Formula is A cross B by mod of A cross B. Since n cap is positive or negative, therefore it can be expressed as plus or minus sign. If n cap is in plus or minus symbol, you will get plus or minus A cross B by mod A cross B. N cap is A cross B by mod A cross B, but you know n cap, I already told you, it is going up and going down. So n cap is nothing but plus or minus A cross B by mod of A cross B. You can find n cap using this result only. Now see the example, find the vector of magnitude, find the vector of magnitude 6 units. So unit vector, and then you have to multiply by 6. If you multiply a unit vector by 6, you will get a vector of magnitude 6, which perpendicular to, A vector, which is perpendicular to vector A, 4i minus j plus 3k, and B vector is perpendicular to A and B, which is perpendicular to both A and the B vector is minus 2i plus j, minus 2i plus j, minus 2k. Minus 2i plus j minus 2. You have to find out the unit vector first. After that you multiply by 6n cap, gives you the magnitude of 6 vector. A and B are given, you have to find out the unit vector perpendicular to both A and B. After finding n cap, you will multiply by 6, then you will get the vector perpendicular to both A and B of magnitude 6. For that you have first to find out A cross B. Determinant I, J, K. A vector is 4 minus 1, 4 minus 1, 3. And B vector is minus 2, 1 minus 2. Minus 2, 1 minus 2. To expand this determinant, I vector, I cap into, as usual, minus into minus plus 2, minus 1 into 3, 3. Minus J into 4 into minus 2, minus 8. And minus of minus 2 3s are 6 into minus of minus plus 6. 2 3s are 6 minus of minus plus 6. Plus K into double minus becomes this minus 6 to plus 6. Expansion will get on minus. Similarly, K into minus 2, 4 2s are A. This is minus 2, minus of minus plus 2, minus 3. J vector is minus 8 plus 6, and K vector is 4 into 1, 4. Minus of the minus plus 2, and expansion minus will get minus 1. So this is I, 2, 3 minus 2I, minus 8 plus 6, minus 2, minus of minus plus 2J, and 4 minus 2 plus 2K. This is your A cross B. And what is mod of A cross B? This is root of 1 square plus 2 square plus 2 square. This is modulus of A cross B. 1 square plus 2 square plus 2 square. That is 4 plus 4, 8 plus 1, 9. Root 9. Root 9. That is equal to root 9 is 3. So mod of A cross B is 3. So we want 6n cap equal to 6 into plus or minus A cross B is, what is A cross B? You write it as plus or minus 6 into A cross B is what? I plus 2J plus 2K. By mod of A cross B is 3. A cross B by mod A cross B. 6n cap, magnitude 6 vector we want, 6n cap is 6 divided by 3 is 2. So plus or minus 2 into I plus 2J plus 2K. This is our required vector perpendicular to both A and B of 6 magnitude. Okay. So see here 3 minus 2 is minus 1, sorry. 3 minus 2, minus 3 plus 2 is minus I. Therefore you get minus I here, therefore you get minus I here. So minus on squaring it becomes plus. Minus I plus 2J plus 2K. So that's all about the vector perpendicular to both A and B which has 6 magnitudes. Okay, that's all about this video, and we will continue the remaining topic in the next video. Thank you.